So I'm happy because at the beginning, like 5 minutes ago, there was only 5 people in the room, so that's better. Um, I know like testing is maybe not super exciting or something, but I think you can really take something from this presentation. So I'm going to talk about like taking care of your UI tests, so more on Android. I mean, the first part is you can use the first part for also web and every kind of UI testing. So just so I have an idea, like who is Android developer here? Okay, almost everyone, good. Who is doing any kind of testing? So not necessarily UI testing, but like testing in general? Okay, and who is doing UI testing? So who is using Espresso, for instance? Okay, a few hands. Okay, good, so I can adapt a bit my presentation. So this talk is not going to be about Espresso. I mean, there's like a lot of really good talk about Espresso and how to start, how to write your first test, and things like this. So this talk is more about how we manage to make our tests grow with our code base. So I'm going to talk about like a project we worked on at my company, and we started from the ground up. So at the beginning, we only had like really a few tests. So at the beginning, it's fine. You have like one screen, 2 functionalities. It's okay to just have, like just the Espresso test right into your test classes. And yeah, it's fine. It's just a few tests. But then as your app grows and you get more and more screens and you get more and more test classes and more tests, you look back at your Espresso test and you're not even sure what those tests are actually checking. And then when you start changing IDs or you start changing the layout, it begins to be a nightmare to just change the whole thing. So this talk is more going to be about how to make sure that you have, as your app grows, your tests stay and are maintainable, extendable, readable, as well as stable. Because most of the time when I talk about Espresso, I hear like, yeah, we don't use Espresso, we don't do UI testing because we tried once and it's just super flaky, it just doesn't work. So just like quickly about me, so my name's Florian. It's a bit confusing because I'm French, but I live in Berlin for now a year and a half. I've been working at Novoda. Novoda has like multiple branches, so we have branch in Berlin, London, Liverpool, and Barcelona. And Berlin is one of those branches. So you can find me like everywhere with this username. So in the past year and few months, I've been working with some people at Novoda Berlin on SoundCloud Pulse. So I don't know how much SoundCloud is popular here in Turkey. Do you guys use SoundCloud here? Yes. Oh, okay, cool. So as you may or may not know, there is actually 200 apps. So there's the listener app, which is the main app, probably the app you use. So it's the app where you can listen to the music and follow artists and write some comments. And there's as well the SoundCloud Pulse app, so that's the app we wrote. And this app is more toward the people who upload the songs and the music. So it's a quite simple app. It's like maybe 10 different screens. And you can get your notifications, so who followed your music. You can get who like your music, and you can follow people, view some profile. You can also like comment, respond to comment, and you can as well see your stats. So in the last week, month, year, etc. And you can also manage your songs, like make them private, public, etc. So if you are not like a creator, so if you don't create music and upload music on the platform, then you probably don't use this app. Is there anyone here that uses this app? Maybe one person? Okay, cool. And so yeah, so I really want this presentation to be more about how we solve the problem of UI testing on our side on this application. So it's going to be like a presentation that is actually talking about really real things, like not, hey, look at this perfect code, that's how you should do it. That's how, in a perfect world, you should do it. But yeah, in my company, we don't do it like this. So this is like just real life example. So we did it, maybe not in the most perfect way, but in a way that works for us. So at the beginning, we also have like some Espresso tests and Espresso code here and there, and it was fine. But then you start, it's But then your tests start to grow, and you have like, I don't know, maybe 10 test classes full of Espresso code that is not really readable. And you're like, it's really hard to extend, to maintain, and to reuse. So we looked a bit around, and we found about the page object pattern, which is a pattern that comes from the web, from the Selenium test framework. And basically, this pattern tells, so it's about like wrapping the screen with an application-specific API. It allows you to interact with the screen element easily, and the test code is not affected by the UI changes. I mean, not directly. So if you change IDs or if you change a layout or something, you don't have to change directly, I mean, the code in your test classes, but you have to change like just the layer above. So why would you do that? The test code, as we're going to see, is way easier to understand. The logic is all about the intention of the test, and you don't care about the UI details. Sorry? No? OK, so here's a simple test. So on the left, the resolution is not that great. But on the left, you have the first screen, which is a track detail. So when you go to your tracks, you can tap on a track, and you see, I don't know, the title, the description, what tags you choose for this track. And you can also perform some action. So we can see here, you can share it. And we can also tap on this like weird 3 vertical dot button that will show this bottom sheet. So that's the pattern we use in this application. Whenever we have multiple options, we show them in a bottom sheet. And then we want here to make the track private. And because it's a really important operation, because if you make your track private and there were like millions of people listening to it, and then the next day there's no one, then yeah, you need to really confirm it. So we pop some dialogue. And then on the last screen, you can see that there's like this little orange lock private text on the right. So that's a full test. That's basically what we want to test. We want to pop this screen. We want to tap on the 3 dot buttons, wait for the bottom sheet to come up, tap on the making track private option, confirm on the dialog, and then assert that this bit of UI, orange lock on the right, is there. So with some Espresso code, that's how you would write it. So you can see it's really verbose. It's like really long. You don't really even know how to indent it properly. So the first line says, OK, on the view with the ID, track detail action more, so the 3 dot buttons, I want to perform a click. So that's easy. The second one is a bit more like, how do I put it? Like, yeah, I didn't even know how to indent it properly. So on the view with the ID, bottom option recycler view, because in the bottom sheet we have a recycler view. We want to perform, so on this recycler view, we want to perform an action on an item inside this recycler view, which has the following attributes. So it needs to be a descendant of all of these options. So it needs to have this ID that is like long as fuck, and this text, and I want to click on this. OK, so you can see it's really not readable. And then this one is quite readable, but it's a bit tricky. So on the view with the ID 100.r.id.button1, I want to perform a click. So why this weird ID? It's actually the framework ID of the confirm button on the dialog. So you write this. It takes you quite some time to figure out how to properly write it. And then you say, OK, it's fine. But then you come back to this like 2 weeks later because, I don't know, you change something in the layout, or you want to add a new test, and you look at the other test, and you're like, what? So using the page object pattern that we just saw before, it just reduced to these 3 beautiful lines. So you get an instance of the track detail screen. You want to tap on showing the track options, and then you want to tap on the option making the track private, and then just tap on confirm. And then when you have like this kind of test in the test class, which are really, you can understand what's happening in like literally 5 seconds, you're all like, finally. So going a bit more in depth, so we chose this pattern, and we chose to like separate the different concerns in 3 different like classes. So we have screens that are basically an interface on, like, I want to make action on the screen, so I want to tap on a button, I want to show a view, I want to really like perform an action. We have the assertion that allows us to assert something on the screen, so assert that the track is private, assert that this is showing. And we have the interactors that are basically used by both screen and assertion. So the screen uses the interactors to perform action, and the assertion uses the interactors to perform assertions. So the screens look like this. And yeah, it's like really simple. And basically, it's like this layer on top of the Espresso code that just hides all this crap inside. And you could really, if you want at some point to use something more than Espresso, let's be crazy, then you just have to change the code inside this. And so then we get like an instance of our track detail interactors. And then here, this screen can only do one option for now, which is showing the track options. And so you get the interactors track actions, which is this button. You perform and click on this. And then you return options. So options is no more or less than also a screen. It's basically a bottom sheet screen, so it's also something that extends from screens and provides some options. And then here you can just say, OK, I want to tap on making the track private option. So I have like a helper method that allows me to tap on whichever option I want. And then at the end of the line, because we know that these actions is really important, I will pop a dialog. Then we say, OK, let's just return a dialog screen then. And the dialog screen is just like a screen that have two possible actions, so either confirming or canceling. And then interactors is just basically like a class that gives you access to views that you want to interact on. So here in this example, the 3-dot buttons and the private indicator, because we want to perform some assertions on it. And we also have the recycler view, because, I don't know, we might want to like perform some assertions or some actions on the recycler view. Assertions, I mean, it's the same. It just take like an instance of our interactors that we saw before, and we have this assertion that is has privacy set to private, and it just checks that the private indicator is displayed. So all in all, we have this test, which is basically, so the first line is given that we are displaying a public track. So it just like pop an activity with a track detail with the right ID that is public. Then we do our thing here. And at the end, we just assert as well. So on this GIF, so it's quite fast, so you have to be careful. But basically, this is the Espresso test that runs. And it literally takes like, I don't know, maybe 2 seconds. Like the GIF is a bit slow. It's really faster. But yeah, we can see just tap on this button, have the bottom sheet, pop the dialog, and then just confirm, and then check. And it's so fast that you can't even see the private indicator. It doesn't even have time to be displayed. So if you want to, so I babbled about this like for 15 minutes. Jake Wharton also like did a similar presentation on what he calls the robot pattern, which is essentially the same thing, minus the fact that he also does the assertion inside the robot, and I think it's always better to just separate concerns. But it's 15 minutes that are interesting at also talking about why it's important to do UI testing. Okay, so it looked kind of easy, but for those who wrote some Espresso tests before, you know that there's also quite a heavy configuring phases, like what do we use when we load the view? I mean, we need some data, we need some fixtures. We don't really care about tracking or crash logs, so we need to deactivate those, et cetera, et cetera. We also need to say to Espresso, wait, I'm doing something in the background, please don't assert, and do some random actions. So this is what we're going to see in this part. So in our application, so in SoundCloud Pulse, we have 3 different types of classes, test classes. So we basically have test classes that test a single screen. So they basically just pop the screen, do some action on it, and then just destroy the screen. That's it. It's not going to go to another screen. And we use this, so for every screen, we test on this. And we have a really simple test that seems a bit silly at first. But for each screen, we have a test that's going to rotate twice the device and just check that it doesn't crash. Because we all know how hard it is to handle properly like configuration changes on Android. So actually, it saves us a few time. We also have test classes that test event propagation, because at the beginning it was just really flat. You couldn't go too deep in the hierarchy, but at some point you could like modify your tracks. And we wanted to make sure that when you modify your tracks and you go back to the tracks list, then it reflects the changes. So if you make a track public and then you go back, you'll see that the private indicator on the tracks list just disappeared. So we wanted to test also this event propagation system. So we have tests that tap on one of the tracks in the list, change the privacy, go back, and check that the event propagation actually works. And we also have like really full-blown scenarios. So we just start the app from the first screen and then really navigate and perform some action as a real user would do. Because usually when we do some UI testing, we directly pop the right screen. And sometimes you want to really make sure that when you start from the first screen, it actually works as well. During testing, we do a really heavy use of the rule in JUnit. So they have been introduced in JUnit 4, I think. And so each of our test class has this kind of, I don't like the word header, but this kind of block of rules, maybe it's a better term, block of rules that configure and define what we want to achieve in this test. So you probably are aware of the activity test rules, so the first one that is highlighted. And basically, so a rule is basically a piece of code that is going to be executed before and after each of your tests. So in this case, activities test rule is actually given by Espresso. I mean, you can find it in the Espresso library. And basically what it does is before your test start, it pop-ups your activity. So in this case, we want to test the user preview activity. So we'll start the user preview activity. It will run your test and then destroy it. And because it's just a rule, it's going to do this for every test in your test suite. And then you have another type of rule, which is the class rule. And this one is exactly the same, but it's not going to be executed between each test. So it's executed at the beginning, then it runs all your test class and all the tests that are in your class, and then execute something at the end. So in this case, it's only custom rules that we wrote. So I'm going to go through each of them. And you can also chain them, so you can be sure that they execute in the order you want. So in this case, we have account test rule, application component test rule, and idling resource test rule. I'm going to go through all of them in details, more in details later. So just to be sure that we understand how rules work. So in the previous example, the outer rule is the account test rule. So it's the first one was going to execute. Then we have the application component rule, then the idling resource rule, then it executes all of our test suite, and then finish the idling resource rule, finish the application component rule, and finish the account rule. So it's kind of, you know, these Russian dolls. Like interesting use of those custom rules. So we have this kind of intro in the application when we start it for the first time. So it's quite simple. It's like just a view pager. There's like, 4 pages. And it just explains like what the app is for and how to use it. And at the beginning, we were just supporting English. And then we started to support Portuguese, German, French. And we realized that those languages are actually way more verbose. Like, I'm not even sure about Turkish, but I think it would be even worse. And basically, instead of taking 2 lines, the translation were taking like 3 or 4 lines. But in our layout, we said we want to cut those lines at 2 lines. And it was just blowing out our own layout and just looks really ugly. So we wrote some tests to make sure that, so basically the test just pop the intro screen, swipe the 4 pages, and assert that the description is not truncated, because we want the user to be able to see all the description, not to be cut in the middle. So the custom test rule look like this. So basically how to write a custom test rule, you just implement test rule, and you have to implement this method. So you return a new statement, and here what we do, then we change the locale. We get the default locale, the actual locale of the device, So in our case, all of our devices are in English. And then for each the local we want to test on, so Portuguese, French, German, maybe later Turkish, I don't know. We change the local, and then we execute the test with just this, base evaluate. And once the test is finished, we make sure that we go back to the local we had at the beginning. So we don't run all our tests in German. So we have also this interesting rule. So we use the account manager in this application. And we want to be able to add and remove on the fly account, because we want to be able to test the app with a popular user, a normal user, or empty user. So it's actually quite interesting to do this kind of test. So you can test that the UI handles well, like when someone has like 14 billions of play every day. So it's like really huge number. It's way too much actually. And we have normal user like you and me, and like the poor empty user that doesn't get even one play in a year. So we can test our UI. And why we have this rule as well is because the app only supports one account at a time, and we also test the sign-in. And so when we test successful sign-in, we need to remove the account as well. Otherwise, the next tests are going to fail because we already have an account on it. And probably the most important rule of all, it's like the application component test rule. So in the app, we use Dagger 2. And we want to be able to swap the Dagger graph, so we can override some components, and we can also disable the crash logs, the tracking, and we can also do something really important, which is telling Espresso when we are doing background tasks, so we can wait. So if you read the documentation, you have this quite interesting paragraph about how Espresso actually works. So by default, Espresso waits for UI events in the current message queue to be handled and for default async tasks to complete before it moves on to the next test operation. So what this thing says that basically, so you write some Espresso code like click on this, perform this, do that, assert this. But then actually Espresso is not super smart. Like it's going to move on to the next step if there is no events in the current message queue. So that's why your Espresso tests will just wait when you have the spinner, because there's some event message in the queue. And for default async task as well. But I hope you guys don't use async task anymore. And what the next part says is there are instances where application perform background operations, which I think is most of the app. And such as communicating with web services via non-standard means, for example, direct creation and management of threads. In such cases, you have to use idling resource to inform Espresso of the app's long-running operations. So this paragraph is exactly why people are saying, oh, Espresso is shit, Espresso is flaky, Espresso doesn't work for us. Because Espresso is not really smart. You have to tell him, wait, I'm doing something in the background, please wait that this thing is over before moving to the next step. So I think I wanted to say something else, but yeah. So an example for this, for instance, I don't know, maybe they fixed this, but for instance, the view pager. If you want to pop a screen and like swipe 3 times and assert something on the first screen, you have to write a custom idling resource, because by default, Espresso is not going to wait for the next page to be completely swiped before asserting. So you have to say, okay, when the swipe is occurring, Espresso, please wait. And when the swipe is over, then you say, okay, Espresso, now you can assert and perform the next step. So we have a really simple idling resource test rule, which is really dumb. It's basically 3 lines of code, but it's something that we don't need to write in our test code anymore. And so you can do, to register idling resources, you can just do espresso.register or espresso.unregister, so it just does this. Basically register, evaluate, so run the test, and then unregister. And we use this mostly in combination with our custom Eric's idling resource. So in the app, basically we do all of our background operation using Eric's. So yeah, how this thing works, like how would you be able to say that to Espresso that we are running something in the background? So as I was saying, we use Dagger, and we have basically a module that is full of execution strategy. So execution strategy is, so I don't know if you guys are like, maybe this part is a bit like advanced, but I will try to go through it and just please bear with me. So it implements a transformer from Observable. And basically it means that then now you can compose your RX calls and operations with this execution strategy. And this execution strategy is just basically going to say to the observable on what to subscribe and on what to observe. I think it's highlighted in the next slide. And we also have like Android strategy, execution strategy that like care about the main thread and things like this. And so basically it means that because we can override components, we can also override the components that contain all of this execution strategy in the module. And we can basically have a direct access to our observable, and every operation we do. So I load the track detail. This is an execution. There is a specific execution strategy for this. I load the tracks list. I don't know. Every backend call have an execution strategy. So for each background task, I can choose to make Espresso wait for it to terminate or not. So I can drop my execution strategy, and basically this is the important part. This is the RX idling resource we use, and we can say, okay, so when we subscribe on the observable, then please, Espresso, just wait. Don't do anything else, and just wait for this operation to be over. And then we hook up with the finally do. So the finally do is executed either when the observable fail, so there is an error, or the observable complete. So basically all the time. And then we say, okay, now it's fine. Now operation is complete. And we call on transition to idle. And Espresso knows that it can just continue and execute the next steps. So just to conclude about the rules are really good for you. They are reusable. So basically, we use almost all of the rules I talked about. We use all of them in almost all of our test classes. It also really unclutters your test from unnecessary details. So using these rules, you don't have to write all of this code over and over and over again. And if you find a bug or something in your test rule, you just have to modify one. And yeah, it separates the configuration from the actual test, which is always a good thing. Separation of concerns. Better failures. So this one is really easy and really easy to put in place. So making the view interaction great again, yeah, news. So basically we have a thin wrapper around view interaction that use a failure handler to provide a human explanation of what went wrong. Because when one of your UI tests fail, you basically get something like this, which is not really super useful most of the time. I mean, you have to go through it and say, okay, so there's like what? An assertion failed error is displayed on the screen to the user, doesn't match the selected view, expected something, and then you have like a huge dump of the view hierarchy, and you're like, okay. So basically on our wrapper, every time before checking and every time before asserting, we just pass an error message, and we use a view failure, a failure handler. And here we just wrap the usual default failure handler and pass him a new custom throwable that's going to contain our failure message. And then yeah, we just execute the default one. And then we get this. So track is not displayed as being private, which is like just way more human than just, hey, here's the view hierarchy dump, and just, yeah, deal with it. So going a bit deeper, in the application we have feature flags. So they are based on the flavor. So basically we have two flavors. We have like an alpha flavor, so for internal testing before releasing the release flavor. So it allows us to develop continuously, so we can just switch on and off the flags. So we basically switch all the features on for the alpha version. So the product owner can test them, and people from the company could test them as well. We had like private beta. And we just have to switch the flag when we want to release the feature. And we can just continue developing even if the feature is not ready by just switching this flag off. So that's great. But how do we deal with testing both the new and the old behavior? Because every time you execute your test, you execute all of your tests, and you might have some tests that are testing the new feature, but if you run this on release, then the new feature are still not there, so it just failed. So we wrote a custom test runner, so it's not as hard as it might look like. And then basically we now have a way to skip tests based on a predicate. So as of now, we just use this to check if it's the alpha or the release flavor. But then you could also go crazy and test, like, I don't know, I want to run this test only if it's running on tablet for something, for example, or only if it's running on phone, or only if it's running on whatever version of Android you want. So it's kind of a really powerful concept. So we have this really nice annotation, which is run when. Basically take a predicate as a value and a Boolean. So if you expect this test to run or not. I mean, if you expect the predicate to return true or false. And here is how a predicate could look like. So some feature flags enabled, and you have two functions to write. So evaluate, so in this case, we have an instance of our feature flags. And basically, some feature will return true if it's activated or false if it's not. So if it's alpha, it will return probably true, and if it's released, it will return false if it's a new feature that is not released yet. And in the description, we just put a description on why this test has been skipped. Then we just extend our classic JUnit class runner. And in the method block, so you have some gibberish class, superclass thing, but basically the important part is this one. So if the annotation is not there, we just evaluate and just return the test, like nothing to do. And if the annotation is present on this test, then we return this predicate statement, which is also quite easy. And basically, the only really important line is the one highlighted. Can you actually see the highlighted line? Yeah, the white one. And so using assume that, you can pass a description, so like just an explanation on why this test would be skipped. And you pass the evaluate, and you say, okay, I expect that this predicate would be true or false. And if it's the case, then it just skips the test, so it doesn't crash. It doesn't do some crazy things. It just doesn't run the test and print nicely test skipped with the description on why it was skipped. And if this is all right, then you just evaluate the test because you want to evaluate. Some Gradle magic thing. So who here has like run the test on like real devices on the CI? No one? Yeah, get a few hands. So the problem with this is that it's real devices. So a shitload of craps can happen with real devices. You have no idea. So we have this really simple Gradle task that is basically going to try to unlock the device if it's locked for some reason before running the test. Otherwise, it would just fail the test because you can't unlock the devices. So it basically looks for every task that starts with connected and end with Android test. We do this because in the middle you have the flavor. So if you want to run all your tests, you will run connected alpha Android test, for instance. And then every time that this task is going to be run, we are going as well to run this bit, which is going to run the force device unlock class, Groovy class that we wrote. That's actually quite simple. It's this one. So extends ADB task, which is a task that comes from the Gradle command plugin that we wrote at Novoda. and basically going to send like a few ADB commands. So you can download on the App Store this app. It's called Unlock Helper app. So if this app is found on the device, then you can just unlock the device by itself. So if we have this app, then no problem, the device is going to be unlocked. We also just try to send the unlock key code. Sometimes it works on some devices, Samsung, for instance. And we want to have the device in like a semi like OK state, so we just try to send it to the home screen. So a few device gotchas. So some of them might be funny, and some of them happen to us actually. So make sure that none of your coworkers are actually shooting OK Google near the CI devices. Otherwise, it might pop the OK Google dialog during the test, which make the test fail. It's really hard to find out what's happening. So you can just deactivate it, I think, or you can just make sure that no one say Google in the entire office, but I don't think it's possible. If you try to assert some code that is written in an edit text, you might find that sometime when you press space, it just puts auto-suggestion, so the autocorrect, and so you're not going to get on the assertion part what you actually expect. Make sure that none of your colleagues is updating ADB while you are running the test. There's also this annoying update dialog that can pop, like if you really want to keep one of your devices on a specific version of Android, and you always have this please update dialog that just pop up. So it can also make your test fail if it pops during the test. So I found out that if you deactivate the service framework, the Google service framework, then it doesn't show this update dialog anymore. But I'm not sure if it's not also like just screwing up all things related to Google services, so maps and things like this. But because we don't use any of those in the app, I'm not sure. Make sure also that your devices are not exposed to the sun, because last summer we had a few failing tests because it was popping up the dialog that says, oh, your device is too hot, I'm just going to shut down. And check on your device regularly. One of our Samsung devices had the battery that doubled in volume. And yeah, it just popped out the screen of the device, which wasn't really nice. And sometime happens, like maybe 1 or twice a month, you have this device that is running this test that is failing for some reason. And maybe in this case, then you want to like just try to reboot this device. Just to conclude, so I really think UI testing is something that is not done enough, especially on Android. I know it's hard, but I don't know, it's really something you should do. It's like, you write unit tests, so it's fine. You know that these units are working, but you don't know if all of this is actually working together. And that's why you really need UI testing. That's actually what you do every time you develop a feature. Every time you change some code, deploy, and you tap on the screen, and you do your functionality and say, oh, okay, that works. But then if you work on a functionality that is actually maybe linked to another functionality. So for instance, in the app, we have this kind of tricky functionality where you can follow user, but if you block this user, then you also need to make sure that you can't follow him or something, and he can't follow you back or something like really tricky. And basically, we developed this, but then every time we are like, wait, did we maybe broke the following functionality? And we had to test the functionality, and it's like, oh shit, we broke it. So you rework on this following functionality, and then you're like, fuck, maybe I again, like just broke the blocking functionality. And with UI testing, it's just running a test class that makes sure that this is still working, and literally takes 2 seconds. So to give an example, maybe we went a bit extreme, but on the SoundCloud Pulse app, we have 300 UI tests that represent so the full testing suite, so counting as well unit testing. It takes maybe 7 minutes to run. But it's 300 tests, and we are sure that the functionality are not broken. We even have like, yeah, so as I was saying, we also have tests that are just testing a specific functionality that is not released yet on some feature flags. So it really gives you like a lot of confidence, and you're not like, Okay, so I just wrote the functionality, but I really hope I didn't broke something else. So if you guys have some questions, I can respond. Yes.
Did you have a chance to work with test a new permission system?
No, not at all. Like, I think the SoundCloud Pulse app is not on this version yet, so we didn't have to deal with this. And I don't think we don't use any permission anyway, because it's a really just read app. You can't really do much. But yeah, I guess it might be tricky when you work with permissions. Do you have experience with this?
Yes, but right now we are just skipping the permissions. We granted the all permissions, okay, and continue the test right now.
Okay. Any other questions? No? So it means I've been really clear, and you guys are all going to work awesome UI tests now? I hope so, I guess so. Okay, so thanks very much.